I wanted to start, I wanted to talk about three things. The first is I want to talk a little bit about where we are politically. Second, I want to talk about proper engineering. And third, I want to talk about the future. Google and Alphabet believe very strongly in diversity and inclusion. Their corporations have beliefs, and this one is ours. And when you look at the agenda that you saw today and yesterday, you can see that we put our money, time, and emphasis where our mouths are, right? We really do care about this stuff. Why do we care about it? Because the platform that we have built, the audiences we have, the things we do depend on a sort of liberal tolerance and order of the world, right? For me personally, my entire narrative comes from an investment in science, optimism, globalization. And we can give you fact after fact as to why the global liberal order, the tolerant one, the one that includes immigration, focuses on education, proper governance, respect for women, gay rights, so forth and so on, all of the things that we all agree on, these are great gains in society. Study history to see how it could be the other way, right? And I will say for myself, I'm worried that we are forgetting these lessons, right? That we fought these battles hard, right? And in the political process and with all the changes that are going on, it's important to remind ourselves that there is not a better way to run the government. There is not a better way to run the world than one that is inclusive, transparent, and full of information, right? Whether it's censorship that we fight, whether it's opportunity, and whether it's empowerment, I think we know the answers. So my position is it's time to fight. This is my personal opinion now, right? It's time to say we don't want the forces of the atavistic forces. We don't want the people who want to push us back into an earlier time. We don't want that. We want the go forward plan, not the go backward plan, right? And I hope we all agree. One of the questions that I think a lot about is why do some things work really well and other things work really poorly in the world around us? And you'll hear in my summary that I think we have a chance to ask some of these questions. So let me use Apple Computer, because I obviously have a conflict with Alphabet. Apple's a great company and build a great product. How is it that Apple can do its products so well, and for example, the prison system in aggregate does a poor job, right? How can we have such an excellent example, right, and a poor example? How can we have empowerment of extraordinary creativity and image, so forth in science, and then we have this rise of inequality? Why do we have a return to some of the original religious and other tensions that I thought we'd put behind us? At the same time, we can build these extraordinary achievements in biology and understanding, right? Why can't we do both well? And my conclusion is that hard things take a lot of time. And that in my interview with Queen Rania, where I've known her for a decade and admire her as a friend and as a leader, I was extraordinarily struck by what it takes to be a leader. And her candid, this is my personal opinion, her candid answer that she had lost her idealism and she became a problem solver. Problem, but they engineered a solution under extraordinary stress, and I admire that so great. So when we think about the things we spend all day complaining about as citizens around the world, why don't we try to engineer these systems in such a way that they work and scale? So if I've learned anything, it's that ad hoc, immediate, as Her Majesty said, black and white answers, they're too simple. That well-engineered dynamic systems take time to think through. They have to be thought through. They have to be engineered. And that furthermore, I would say to you, whether it's discussions about the universal basic income, right, or other political matters, why don't we try a few? Let's run a few experiments. Let's be a little bit less dogmatic. Let's try over here one approach to the drug problem, and over here another one, and another here to the opioid problem, which is, I don't know how bad it is in the UK, but it's terrible in America. These are things which ravage families and so forth. Let's try some experiments and engineer some outcomes and see what works, right? Think like an entrepreneur. So if you take that attitude, then let me tell you what's going to happen. Because something has happened in the last few years that will be a platform to solve some of the most extraordinary problems that we have in front of us. And it's the development, and Mustafa talked about this, the development of essentially deep learning, deep neural networks, and so forth. The technology behind these things are that, think of it as our brains are networks of neurons that span and branch in complicated ways that no one understands. Eventually, probably 100 years from now, the brain will be fully understood and mapped, but not today, and not for a while. So these deep neural networks can be trained, and they can learn, and they can begin to do some human-like technologies. And this has become the mantra, the obsession of our industry. Sundar, who now running Google, says we're an AI-first company. Now, why would we do that? Because everything we do has a lot of data, a lot of training data. So one way to think about it, and I had to learn how to think about these problems, is any situation where you have a lot of data, you can probably learn a better outcome than what we're doing now. So to be blunt and direct, the good news about terrorism is it's a very rare event. Therefore, there's not a lot of training data. So unfortunately, that's not a good example. But what about traffic? Okay. What about people's daily lives? What about energy usage? What about information flows? What about politicians speaking? Right? There's lots of it, right? We can train against these things. We have enough data we can learn, analyze, and understand. So the result of it is I will say to you that the following problems are now solved. Computer vision is a solved problem. Computer vision is now roughly equal to human vision. Computer speech equal to human and computer language translation near equal to human. What does it mean when computers' vision and speech are human-like, good enough? Well, the most obvious one is everybody here arrived in a motor vehicle. How could you possibly let a human drive one of those things? I mean, this is like a serious error, right? I mean, let's go through the errors. The first is, as far as I can check, everyone only has eyes going forward, right? Our cars have eyes going backward, right? So you can see them hit you from the rear better, right? Or whatever. More realistically, you can see the bicycle to the side of the car, right? If you're the bicyclist, you want a self-driving car next to you, trust me. If you think about it, it's crazy that 100 years ago this was legal, right? And the only reason they did it is because they didn't have computers that could see well. What about, my favorite example is dermatology. So you go to the dermatologist looks at the skin, says it's not cancer. And I, of course, being nervous, say, well, it looks like cancer. I looked at the picture, said, no, it's not cancer, Eric. You need to stop worrying. And I said, well, how do you know? I said, well, I look at skin every day. Well, we've now trained computers that look at skin more accurately than dermatologists. How is that possible? By the way, we're not better dermatologists. We see more skin. We see 1 million pieces of skin. The dermatologist sees 100,000. In our case, probably 100 million pieces of skin. You get the idea. So if vision is a solved problem, then the kind of gains that you can get in medicine in terms of efficiency, it doesn't mean that the National Health Service is not going to be overloaded and busy, but it means that you'll get better healthcare outcomes, that the doctors will be more efficient. We won't have fewer doctors, but they'll be more accurate because they're human-aided. What about energy? We have the world's, we think, most powerful data centers. A technology from here in Britain was used to improve the energy efficiency by 15%. Now, you say, oh, that's not very much. 15% in an energy distribution network? That's all of the profits and most of the pollution on the margin. Because remember, the pollution is related to peak usage, right? Not base usage. So all of a sudden, you reduce the dirtiest sources of needs and power. Think about the impact of that. Okay, pretty good. We're working, and others are working on education, providing the same problem. Again, you can train against students, lots of students, we educate everybody, learning how people learn better by having a back channel signal. So why is this so important? I'm asserting to you right now that these are known and solved problems. Now you sit there and say, well, what drug is he on? And the answer is, how do I know this? Because we and others are building this world. And the only thing separating it from being in your world is time, and in some cases, regulation. As a funny story, and there's differences in America, we're doing our self-driving car testing in a number of states, including Arizona, and not in California, because the laws allow for more rapid testing in Arizona. So there are differences. But you can be sure that once this stuff works in the states that allow it, and people continue to die in the states that don't allow it, they'll be allowed. Right? It's how human progress works. But let me sort of say what I think is going to happen next and then finish up. The reason to think that this is not the end is precisely because what happens next. Self-driving cars, improvement in medicine, much, much better education. They'll help us solve all the real problems that I'm describing. And much of this work is being done in Britain here at King's Cross. It looks to us that you can now begin to do something called, the technical term is generative models, where what you do is instead of just studying something and answering it, like vision or so forth, you can begin to generate models and test the models. You try a model, test it, try a model, test it, try a model and test it. Now you sit there and you go, what's he talking about? A lot of what we do is around, what do you think? What is your opinion? You have dreams, you have an idea, you have intuition. We're beginning to be able to run experiments where we try something, and using technology developed here in Britain and in other places, we can begin to do a fast-forward scenario. Well, what if, and what if, and what if? And then evaluate, and then the ones that we like, back-propagate, a technology that was invented in math in 1981. So it's not that old a technology to bring this thing back forward. What does this mean? It means that you can take pretty much any set of data, and a normal programmer, as opposed to the sort of bespoke programmers that we have today, can do this. We call this learn to learn. You can basically take the data and learn how to learn against it. With that, we begin to be able to ask the questions that I highlighted earlier on engineering, that we can begin to ask questions that are profound. We can begin to say why and why not. Let's run this model. We have the data now. So whenever you have a large collection of data and you have a question, it should be possible to pretty much automatically begin to answer that question. And whether it's things like climate change, which is still occurring, by the way, even in the United States, shocking. Even with modeling and ideas, anyone can do it. This democratization of this technology is profound. And in order to do it, what we need is another factor of 100 of computing power, right? Because the models, we're essentially generating models. We're sort of learning how to generate choices. Is that achievable? Well, my guess as a computer scientist is we see maybe another factor of 10. So maybe we'll find another factor of 10 with science and research and so forth. But this is the cutting edge. And what I like about this is you want to know where is the puck and skate to the puck. That's where the puck is going. Skate to where it's going. And it has some interesting properties. So she is busy training a car to turn left, and he is busy training a car to turn right. Right? And you train it for a while, and it learns how to go right, and she trains her car to turn left. At which point, the car can only go left, and his car can only go right. But there's something very interesting about this. You then build a library. She and he combine their models, and the car can turn both ways. By the way, humans can't do that. Think about the implication of that. If we can begin to build these knowledge networks, to build that level of assistance for what we as humans do. I am convinced that the next 5 to 10 years will be another glorious age of innovation. that the discoveries, both the statement of the problems, which I tried to elucidate, which everybody here knows, and then this platform that is being built, broadly shared across the technology and science industries, will result in both extraordinary rate of innovation and new discoveries to bedevil problems that we've had forever, but will also allow us for the first time to be able to address some of the problems that we've not been able to solve. And that's why I'm so incredibly optimistic about the next 5 years. And I hope that is the core message that we have delivered and have you feel as our guests here at the conference. Thank you all. Thank you, Matt.